Hello and welcome to another Cashmatics video. In this video we'll be looking at integrating functions of ax plus b. So the kind of functions I'm talking about are functions like these. So as you can see, the bits in orange are linear. Okay, so they're a function of another function. So e to the power of a linear function, which in this case is 3x plus 1, cos of 4x minus 3, etc., etc. But just remember, the linear function doesn't need to have the b, but it does need to have the ax. Okay, so for example, this last one here is the cosec of 7x multiplied the cot of 7x. Okay, so I don't need to add or subtract anything off it, but I do need the ax bit. So grab yourself some paper and a pen and just work along with me. Right, so we'll start with these ones that are on the board, and the rule is actually quite a straightforward one. Once you've integrated the main function, now when I mean the main function, so this is the exponential function, this one's the cos, this one's the sec squared, this is a reciprocal function, so 1 over 4x minus 5, and this is a cosec cot x type function. All you really need to do, well, not really need to do, all you actually need to do is divide by a. That's it. Okay, so I'll show you what I mean by that. So e to the something, when you integrate it, becomes e to the something. So in this case, I'll still have e to the 3x plus 1. And all I need to do then is divide by 3. So divide by 3 plus c. And some people like to write this as 1/3 e to the 3x plus 1 at c, but that's entirely up to you. This one here, now when you integrate cos, it becomes sine. So you have the sine of 4x minus 3, and all you need to do then is divide by 4. So divide, let's draw that a little bit neater. Divide by 4, add c. Okay, this one here. Sec squared, when you integrate it, becomes tan. So this will be the tan of 5 minus 2x, but I've got to remember to divide by minus 2. Add c. Now you could write this as minus a half tan of 5 minus 2x. Add c if you wanted to, but like I said, that's entirely up to you. It does look a little bit neater like that. This one here, it's a 1 over x type function, where the x is, instead of the x, you've got a linear function. So 1 over something becomes ln. So this will be ln of 4x minus 5. Don't forget the modular signs. And I just need to divide by 4. So divide by 4, add c. And this one here, if you recognize it, this is where I said, have these in your memory if you can. Okay, cosec x cot x comes from cosec x. So the derivative of cosec x is minus cosec x cot x. So the integral of cosec x cot x will be minus cosec x. But instead of x, I've got 7x. Now you've got to make sure these two angles are the same. It'll only work if these two angles are the same. So they both have to be 7x or whatever they are. They need to be the same. So this will be minus cosec 7x divided by 7. Add c. So there you go. It's as simple as that. But obviously the questions you get in an exam aren't going to be as simple as those. But that's your foundation. So what we'll do is we'll move on to some slightly more tricky examples, but that's the foundation of it all. So yeah, if you need to pause your video and make some notes, and then we'll get started with some more complicated examples. So this is our first example, the integral of 3 sine a half x plus 1. So you can see there's a linear function here. Okay, that's a linear function. So all I need to do is just remember to divide by a half, which is the same as multiplying by 2. Okay, so let's just give that a go. So sine becomes minus cos, so that would be minus 3 cos a half x plus 1 divided by a half, add c. Now, as you get more and more comfortable with this, you might just be able to do this step in your head, but that becomes minus 6 cos a half x plus 1, add c. So nice and easy. So we'll do something a little bit more complicated than that. So like I said, make some notes if you need to, and then let's get on with this next example. Okay, here's the second example. So we've got some brackets here, so we need to expand the brackets first before we do any integrating. So the integral of, now this, you can take your time expanding this, but this will become e to the 2x plus 2e to the x plus 1 dx. Right, so we've got a linear function here. Okay, so e to the x becomes e to the x, but this is e to the 2x, so this will be e to the 2x over 2 plus 2e to the x. Now e to the x just becomes e to the x, so 2e to the x plus 1, which becomes x, add c. So we just, there's only one thing to really do here, that was expand the brackets, and after that it was actually quite straightforward. Right, let's move on to the next example. So here's the third example, the integral of sec squared 2x brackets 1 plus sine 2x dx. First thing to note is the two angles in the question are the same. Now that's not always important, okay, but in this case it is, because one of the terms I'm going to get is a combination of the sec squared and the sine, and these integrals only work if each individual term is made up of the same angle within the term. Okay, it doesn't matter if one term's got 2x and the other one's got 3x, that's fine, but you can't have a single term with a 2x and a 3x inside it, because they'll just be a lot more difficult to handle. Okay, so brackets. So the first thing we do is expand the brackets. So the first the first term becomes sec squared 2x plus the second term, which becomes sec squared 2x sine 2x dx. Oh, and don't forget the integral sign, not integrated yet. Okay, the first term, nice, sec squared becomes tan, but let's just keep it as it is for now because we're not integrating just yet. Sec squared 2x plus sec squared 2x, I'm going to write as 1 over cos squared 2x multiplied by sine 2x dx. And I'm just going to rewrite it again. So this is sec squared 2x plus, now I'm going to split this up slightly. Look, sine 2x, I'm going to write it as sine 2x over cos 2x times by 1 over cos 2x dx. Now the reason why I've done that is because hopefully you'll recognize something here. Okay, so the first term, keep it as it is. This is tan 2x. And 1 over cos 2x is sec 2x. So tan 2x, sec 2x, which I'm just going to write the other way around. So sec 2x tan 2x dx. Okay, now the reason why I've done that is because this is a standard integral, isn't it? Sec x tan x comes from sec x. So sec 2x tan 2x comes from sec 2x. Okay, so now we're in a position where we can actually integrate. So let's just go over here. The first term, sec squared 2x, becomes tan 2x over 2. Don't forget to divide by the coefficient of x. Plus this becomes sec 2x over 2. And don't forget the constant at the end. Okay, so a little bit more complicated, but just do it step by step. Manipulate the functions until you get something which you recognize, and then integrate as usual. But don't forget to divide through by a. Right, so this one here, let's have a look. Now this one does look a bit nasty. So let's see what we've got. We've got 3 minus 2 cos a half x, sine squared a half x. So half x is the angle in both of those terms, so that makes it nice and easy. I'm just going to remember, at the end, when I'm integrating the trig functions, I need to remember to divide by a half once I've done it. Okay, so let's see what we could do here. Now, the first thing I would be tempted to do is just split the fraction. Okay, so this becomes 3 over sine squared half x. Take away 2 cos a half x divided by sine squared a half x dx. Okay, and whenever I'm doing these, I'm always looking for ways to rewrite them in a form I can recognize. Okay, so I know sine squared, but that's not an integral I recognize. So what I would do is, because it's 3 over sine squared, I can write that as 3 cosec squared, a half x. Okay, and I know I can integrate cosec squared because the derivative of cot is minus cosec squared. So I know I can integrate that. Take away. So I'm going to rewrite this a little bit. So I'm going to rewrite this as 2 cos a half x divided by sine a half x multiplied by 1 over sine a half x dx. Okay. Now I'm almost there now. Okay, the first term I'm happy with anyway. So 3 cosec squared a half x, take away 2. Now look at this bit here. Cos over sine is cot, 1 over sine is cosec. So I've got a cot x cosec x, or in this case cot a half x cosec a half x. I'll write the cosec first. So cosec a half x cot a half x dx. Okay, and now everything is in a form which I recognize as an integral. Okay, so if you haven't got your formula book open, just get it open, have a look through the derivatives and the integrals. You'll see that the derivative of cot x is minus cosec squared x, which means the integral of cosec squared x is minus cot x. So this will become minus 3 cot a half x. I've got to remember to divide by a half. So divide by 1/2. Take away. You'll see in the formula book, cosec x cot x is the derivative of minus cosec x cot x is the derivative of cosec x. So the integral of cosec x cot x would be minus cosec x. Now I've got a minus here as well, so a minus and a minus will make this a plus 2 cosec a half x divided by 1/2. Add c, and I'll just write this a little bit neater over here. I didn't need this integral sign here because I've integrated at this point, so keep that like that. Okay, so let's just tidy this up. So minus 6 cot a half x plus 4 cosec a half x, add c. That's the final answer. So hopefully you can see that it's not actually that difficult, as long as you're willing to take things one step at a time. So I think the most difficult part of this is manipulating your trig functions to get them into a form you actually recognize. But once you recognize it, it's actually dead easy from that point. So if you're struggling with the trig part, what I would suggest you do would be to just practice proving identities and things like that. That'll help you to manipulate these trig functions. But other than that, all you've got to remember to do is, once you've integrated, you just divide through by a, and Bob's your uncle. Right. Hope that's helped, and I'll see you next time. Goodbye for now.